Hello everyone. So today's problem is let x is equal to a set which contains from 1 to 10 and set A is equal to 1, 2, 3, 4 up to 5. Then the number of subsets of B of x such that A minus B is equal to singleton 4 is what? So options are given. This is the question from Kerala PET exam. Okay. So now what is given is actually they have given one underlying set, that is x, that has a numbers from 1 to 10. Fine? Yeah. And they have given another set A that has set numbers from 1 to 5. Okay. Now they have given another data, that is A minus B. There is some set B such that if we subtract that B from A, we are getting singleton 4. So now what could be that B? The exact question is how many number of such B sets we can create. Let me make it more clear. Suppose for example, if we have a set B is equal to say some 1, 2 and maybe okay, maybe simply 1, 2 means what will be our A minus B? In that case our A minus B will be, this is 1, 2, so that will be 3, 4, 5, right? If this is our B, our A minus B. So, but they have given A minus B is equal to 4. So, of course, so we can conclude this is not our B. But for example, if we take 1, 2, 4, 1, 2, 3 and 5. In that case, what is our A minus B will be? This is 1, 2, 3, 4, 5. This is 1, 2, 3, 5. So, in that case, our B will be 4. Yeah, fine. So, this is one of our B sets, right? If we take B like this, then we will satisfy the given data, right? But this alone need not to be our B sets. See, look at here, if we add 6 with this, maybe in that case also our A minus B is 4. If we add 7 with this, maybe in that case also our A minus B is equal to singleton 4, right? So like this we can create many B's, right? So how many such B sets we can have? That is our question. So now formally let us enter into the problem. So now from the given data, A has 1, 2, 3, 4 and 5, right? So we are guessing that, see, in A minus B has only 4. So we can assure that what is A minus B? We collect the elements from A which are not in B. A minus B doesn't have 1, which means the one which is in A which is also present in B. Am I right? Then only in A minus B 1 is not presented. Okay. So 2 is here, but 2 is not in A minus B, so 2 will be here. 3 is here, but 3 is not here, so 3 will be here. 4 is here, but in A minus B we have 4, which means what we can conclude is, of course, 4 is not in A, not in set B, right? So 4 does not belong to B. This is sure, right? Yeah. So 5 is here, but 5 is not here, so 5 will be in B. See, about these 5 elements, we can have a concrete decision of this, right? Since A is 1, 2, 3, 4, 5, B is A minus B is equal to 4, we can assure that 4 does not belong to B and 1, 2, 3, 5 are belong to B, right? About these 5 elements, we can have this concrete condition, right? But what are the remaining elements are there? Remaining there are 6, 7, 8, 9, 10, right? But if 6 present here also, our A minus B will be singleton 4, even if it doesn't present there. Same thing, if 7 here also, we will be having A minus B is 4. If 7 doesn't belong to there also, we will be having singleton 4. So like this. So the remaining elements 6, 7, 8, 9, 10. There are 5 elements. This is one of our required B. So remaining there are 5 elements. With these 5 elements, how many B sets we can create? That is the B set we are looking for, right? So now you have to answer. Actually, we have discussed about this earlier in the sense, see, 6 can present in B or not present in B, right? Anyhow, that will be our required B. 7 may belong to B or may not belong to B, right? 8. So like this, each element has 2 possibilities, am I right? This element may belong to B or may not belong to B. this element may belong to B or may not belong to B. So this has two possibilities with respect to the set B, this has two possibilities with respect to B. So like this, there are 5 elements. These 5 elements with respect to the set B have totally how many possibilities? 2 into 2 into 2 into 2 into 2. 6 has 2, 7 has 2 possibility, 8 has, so like this there are 5 elements. So totally we will be having 2 to the power 5 possibilities, which means 2 to the power 5 B6 we can have from the given data. Do you get it? So this is the content I have already made a question that if a set has n numbers, why the number of power sets of if a set has n elements, the number of subsets of a set is 2 to the power n, right? Because the answer is, if a set has n elements and we are creating a set which is going to be a subset of that, each element has 2 possibilities, right? Either the element which you take may belong to the set or may be out of the set. The second element which you take from the n elements may belong to the set or may out of this set. So like this, there are n elements and each of the element has 2 possibilities, so that altogether we can have 2 to the power n possibility. Okay. For more detail about it, you can contact us. Thank you.